Have you ever felt stuck trying to get your neural network to produce the right outputs? It can be really frustrating when you're aiming for a specific range and it just won't cooperate. If that's you, you're in the right place. Today, we're diving into how to get your neural network to output values between -1 and 1. I totally understand how challenging it can be to adapt a neural network for different outputs. Many tutorials focus on binary outputs, which can leave you scratching your head when you need something more nuanced. You're definitely not alone in this struggle. Here's the specific situation we're addressing today. One user asked how to modify a backpropagation neural network to produce outputs in the range of 0 to 2 times pi, or from 0 to 255. They noticed that the existing examples always resulted in binary outputs, and they want to know how to change that. Sound familiar? Let's explore this together. So what's causing this issue? The problem lies in the activation functions and the way outputs are computed. The softmax function, for instance, is designed to produce probabilities, which is why you're seeing binary outputs. We need to rethink how we handle the output layer to achieve the desired range. And stick around. At the end of this video, I'll share a crucial tip that will help you modify your neural network effectively and avoid common pitfalls. To modify the neural network for non-binary outputs, the user should start by changing the activation function used in the output layer. Instead of using the softmax function, which is designed for classification tasks, the user can implement a different approach that allows for continuous outputs. Next, the user should adjust the output layer's weights and biases. This ensures that the network can learn to produce the desired range of outputs. The user can initialize the weights and biases to appropriate values that allow for flexibility in the output. Now, the user needs to modify the training process. Instead of using a binary cross-entropy loss function, the user should implement a mean-squared error loss function. This will help the network learn to predict continuous values effectively. Finally, the user should test the modified network with sample data to ensure it produces the expected outputs. This involves feeding the network input values and checking if the outputs fall within the desired range. Fun fact: did you know that the first neural networks were inspired by the way our brains work? They've come a long way since then, but sometimes it feels like they have a mind of their own. Now, let's look at the answers provided by other users. An alternative approach suggests using a linear activation function for the output layer. This allows the neural network to produce a range of values instead of just binary outputs. By implementing this linear function, the network can now output values that are not limited to binary results, providing a more flexible range of outputs. Here's the tip I promised: always visualize your outputs during testing. This simple step can help you quickly identify if your network is behaving as expected or if adjustments are needed. And there you have it. With these adjustments, your neural network should now be capable of producing outputs in the range you need. Remember, experimenting and fine-tuning is key. If you found this video helpful, please subscribe for more tips and tricks on neural networks.